Cool. Right, this is a lightning talk. Most of you know me. I'm Payne on GitHub. This is my 15th talk at Meetup. This is a very short one.
Thank you, Tom.
All right. But more new speakers, please. Please do not be shy. It's a friendly crowd. Enjoy it. So this is a little project that I wrote. I thought was quite useful for others. It's a fairly common pattern in Go where you have a bunch of work to do. Yeah. Is that okay? More?
Yes.
Okay, cool. So it's a pretty common pattern. You have a bunch of work coming in that you put into a channel. And then you have a bunch of workers that consume work from that channel and iterate through it. This is very simple. Go supports this really well. But sometimes that work that's coming in, some of it is more important than others. A specific example, previously I gave a talk on finding duplicate files very quickly. And here you need to scan files to calculate hashes of their contents. The overall runtime of the program is one thing you can't do is like the largest file, you've got to scan all the way through that. So if you want to reduce the overall runtime of the program, you want to start scanning the big files as soon as possible. So that you can then in parallel scan the little files. If you leave the big files until the end, then that's going to be added on to your total runtime. So I needed some way of prioritizing something. I want to work on the importance of the big files first. The net API that it comes up with is very similar. This is the same code, except I've got 3 extra lines here, which is this prioritized work channel. As input, I have a buffered. This has a buffered aspect to it. I give it a context for cancellation control, my existing incoming stream of work, a size, and a function to prioritize the work. And I will just actually run some code so you can do this, see this. I run, this is what we're doing here is squaring the numbers 1 to 100, and the numbers are coming in order. But I want to square the bigger numbers first, as an example. So, I add in the priority channel. And what this is going to do is it's going to read work in, store a little buffer of 20, and take the highest priority from that 20 it's seen so far. And these workers are now going to start receiving the work in that priority order. If we run this, so the code is similar, but now runs, uses the priority channel, what we find is that the workers are now dealing with the bigger numbers they encounter first, and the very small numbers, which are never the priority, get dealt with right at the end. So this is a very simple way of prioritizing work. Under the hood is a very common data structure. Who's encountered heaps before? Or a lot of you? Okay. So the underlying data structure, it's a nice little bit of Go generics, is a heap is also known as the priority queue. It's a data structure which is effectively partially sorted. You can add data elements to it, find the smallest very quickly without having to sort all the elements as they come in. I strongly recommend reading on the Wikipedia article on it. There's a really neat way you store the whole thing. It's actually a binary tree data structure, which has the property that any node is higher priority, in this case less, than its 2 children. That means the highest priority element is always at the top of the tree. When you want to add a new element, you basically put it up at the end of the tree and then bubble it up to the tree as necessary. There's some really nice ways of representing it as a single slice. And the key thing is, let's do the shift up. The thing on this is a slide. Things are indexes. You can immediately go to the parent of a node by dividing the index by 2, pretty much. And you can go to the child of a node by multiplying the index by 2. So you get very fast operations. This heap is the underlying data structure. The buffered channel, then, or the priority channel, there's actually 2 variants, but the buffered priority channel, it maintains a heap of whatever types you're running, using nice generics here. We pass in the less function, our prioritization function, and then, well, you can read the code. pre-fill up the size, prepare to send stuff, and then we send stuff out. As consumers take in work, we can read in new work and use our heap to find the next highest priority thing. We keep going until we're done, basically. And that's it. That is Priority Channel. It's 3 lines that allows you to prioritize your work. It comes in 2 formats. The buffered Priority Channel will read up to n elements and is here 20 and maintains the last 20 it saw. There's also a non-buffered Priority Channel which greedily reads as many as work elements as it can, like items as it can. This, of course, has potentially unbounded memory use as it reads all the things into this heap data structure. And that's it. That's Priority Channel. Hopefully you'll find it useful.